1-7, we are in geometry, 1-7, three-dimensional figures. So last time we looked at one-dimensional figures, and now we are looking at three-dimensional figures. Okay, so an enclosed three-dimensional figure is called a polyhedron. You're welcome. Now, let's go ahead and draw a three-dimensional figure. So what we're going to do here, we're going to draw kind of this upside down looking kind of box, kind of. Okay, so we're going to start by drawing a kind of a skewed rectangle. And then we're going to draw some lines coming down from each of these edges that all the same length here. Then we're going to connect these two. We're going to connect these two. And now, from this point, we're going to draw a dotted line that goes back this way. Stops about right there. And then we're going to connect these two vertices with a dotted line, and then we're going to connect these two vertices with a dotted line. Boom. Now, this area right here on the top is called a face, but it can also be right here. Any of these sides is a face. Face, which is also known as sides. So that's the face. Now, the part here on the edge is the edge. So not the flat part, the point at the end, that's the edge, that's the edge. And then any place where two line segments meet, those are called, each are called a vertex. Okay, so there are the parts of a polyhedron. Now let's talk about some different types of solids. So we've talked about polyhedrons, but we're going to talk about them in a little bit more depth here. We've got polyhedrons, which are, we're going to look at a prism. So the prism has two parallel and congruent faces called bases. Two parallel and congruent faces called bases. So let's draw one. So we're going to start with kind of like almost a home plate kind of a looking thing, or an upside down Superman logo. Okay, now this is going to be a base. And so we need to draw another one that's exactly the same as this one, and we're going to draw it lower than this. Okay, but before we do, we're going to go to each of these vertices, and we're going to draw a short line segment going straight down. The same size from each one of these. Now from the top, we're going to make it a dotted one. And now we're going to connect each of these endpoints And now we're going to connect these last endpoints with a dotted line. So now this looks like it's got one base on top, one base on the bottom. They're congruent and they're parallel. And this is a base, and underneath that's a base too. So these are the bases. Now we're going to look at a pyramid. A pyramid, let's draw this pyramid this way. Let's draw a triangle. And then let's just draw one line that kind of comes back here like a tail. And then let's connect that with the top. The top, which is called the vertex. Now, let's draw another line in the back here, and we're going to draw it this way, stop there, and then we're going to connect here. Then the vertex, we're going to drop down like that, and we have a pyramid, and down at the bottom of the pyramid is the base. So those are the two kinds of polyhedrons that we're going to look at here for this section. And then we're also going to draw some non-polyhedrons that are solid still. So non-polyhedrons. And so for these non-polyhedrons, we have a cylinder. Cylinder. Is it supposed to be cylinder with an A? I could have sworn that was supposed to have an A. Well, I guess not. All right, I spelled it right. Cylinder. We're going to draw a cylinder with like a squished circle or an oval. Then we're going to draw a line from each end that's the same distance as the other one. And then we're going to draw half that same circle that we drew above, solid, and then the other half of it dotted. So now we have a cylinder. This is the base, and this is the other base down at the bottom. We have a cone. Now for a cone, we draw kind of the two sides of a triangle of the top, and then the base here, instead of drawing straight across, we're going to draw it rounded, and then we're going to continue that oval into the back. This down here is the base, and up here, that's the vertex. And then one more non-polyhedron is a sphere. So for a sphere, we're going to draw a circle. We're going to draw a center point here. And then if you draw a radius, that's helpful too. Now, it doesn't really look like a sphere, it just looks like a circle. So what we can do is we can draw an oval inside of it, right around like the midpoint. And now it looks a little bit more like a sphere. Okay, we're going to draw some more polyhedra. Names, we're going to draw some names of polyhedra. And they are named by their bases. Okay. Here we go. We are going to draw a little triangle because we don't have a whole lot of room. And then we're going to draw two lines, line segments that are the same distance, same length going back, like that. And then we're going to connect these two here, and then we're going to say, look, there's a triangle, and then we're going to connect those two guys there. Now we have a triangular prism. Now, we are going to draw a kind of a skewed square or a rectangle. And we're going to draw a rectangle here. We're going to draw this same line segment right here, and then we're going to connect them. And then we're going to draw this same rectangle right here, but dotted. And then we connect these two vertices, and this is called a rectangular prism. We've got 4 more of these guys to draw. Now, we've already drawn a pentagonal prism, but we're going to draw another one. So this is the one that looks like home base. We're going to draw straight down from each one of these and a dotted one up here. We're going to connect all of these guys and then connect this one to this one. And we have a pentagonal prism. All right, now we're going to draw 3 different pyramids. So first we're going to start with a triangle. Then we're going to draw a little kind of triangle coming off the back here, and then we're just going to connect these two. That is a triangular pyramid. Notice the base is a triangle. Back up here when we drew this triangle, it had a rectangle for a base. This one has a triangle for a base. Let's do another pyramid. We're going to start again with a triangle. And then we'll draw another triangle off to the side like this. And this time we're going to draw straight over horizontally, stop, straight down, or not straight down, but over to the edge, and then another one back there, and we have a rectangular prism. A pyramid, sorry, not prism, pyramid. And the last one we're going to do is a triangle. And then we'll draw a little triangle coming off the side again. We're going to draw a triangle coming off the side of this one. And we're going to, now we're going to draw a dot, 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 dot right here. And this dot, dot, dot is going to connect over to this one, connect over to this one. And you have a 1, 2, 3, 4, 5-sided base for this rectangle. And so this is called a pentagonal pyramid. Let's keep moving. Let's do just a little bit of an example. I'm going to draw what looks kind of like a mattress. So here is a rectangle that's kind of squished on its side. And then I'm going to draw a line segment down this one and like that, and they should all be the same size, and then one that's dotted back there behind. Then I'm going to connect these two guys and these two guys, and then I'm going to dot, 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 connect. And here I have a rectangular prism. I'm going to label all of these vertices. So I'm going to start with the top part here, and this one is R, S, T, and Q. And on the bottom I've got M, N, O, and P. And so my bases for this rectangular prism are rectangle SRQT, that's the top, and rectangle NMPO. That's the bottom. And notice they correspond. S and N, T, O, Q, and P, R, and M, they correspond here. I grew up in Nipomo. That looks like Nipomo. All right. Let's go ahead and let's keep going. Let's talk about a regular polyhedron. All faces regular and congruent. All of the faces of a regular polyhedron are congruent and they're all regular, meaning they have the same, all of their sides are congruent and all of their angles are congruent. So another way to say this is Platonic solids. So there are only a few of these that exist, and one is called a tetrahedron. This is 4 equilateral triangles. Another is a hexahedron, or also known as a cube, which is 6 squares. We also have the octahedron, which is 8 triangles. Dodecahedron, which is 12 pentagons. This one you might recognize as a soccer ball is often made up of 12 pentagons. And also the icosahedron, I'm not sure exactly how to say that, 20 triangles. Sometimes I've seen soccer balls that are made out of 20 triangles as well. Or sometimes soccer balls are a square and a hexagon, and well, anyway, a variety of shapes. But I've seen it 12 pentagons before. All right, let's keep going. We are almost done with this. I know this is kind of a long, drawn out, but we need to look at surface area and volume. Okay, surface area and volume. You can kind of think of these as kind of like, this is kind of like the perimeter, and this is kind of like the area. Kind of. When you're talking about two-dimensional figures, you've got the perimeter and the area. Three-dimensional, you have surface area and volume. So the surface area is all of the area of the sides added up, and the volume is how much space this whole thing takes up, or if you were to fill it up, how much space how much stuff would be inside of it. So a prism, we're going to draw a prism. All right, we have a rectangle, and we're going to draw some lines going off the back here. They should be the same angle and the same length. Then we're going to connect these guys, and then another one back here, and then we connect those guys. We have a prism. Surface area is all the sides, the area of all sides added together. And the volume is the area of the base times the height. So this big B here means the area of the base. So area of all sides added together gives me the surface area. The volume is the base, the area of the base, times the height. Regular pyramid. So I've got a triangle. Oh, not regular. It should be rectangular. Rectangular. Rectangular pyramid, so that the bottom is a rectangle. So the surface area, all the sides added together. Bop. The volume is 1/3 area of the base times the height. So you find the area of the base and you find the height, divided by 3, and you've got the volume of a rectangular pyramid. Cylinder, draw a cylinder, we draw a flattened circle, 2 lines coming down, dot, 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 circle. Surface area, this is a long, kind of drawn out one, and if we were in class I would spend some time trying to explain it. Surface area is 2 pi r squared. That's the area of each of the bases. And then you add the rectangle that would be joining those together around the outside, which would be 2 pi r times height. So that's the circumference of one of these circles times the height. So that will give me the rectangle there, because this would look something like this. If I was to flatten it out, like a roll of toilet paper or something, if I cut it in half, then I would have that, and then if I were to plug those two, the 2 holes on the end, I've got 2 pi r squared, that's the area of these 2 guys. 2 pi r times height is the area of that shaft, is what you call it. Okay, cone. Let's draw a cone. We're going to draw it upside down this time. Here's my radius, and then there's my height. And then here, this side is my length. And so now I got my surface area equals pi r length plus pi r squared. So this pi r squared is the bottom here, or the top, or whatever, this base. And then pi rl is the surface area of the cone part. The volume is 1/3 pi r squared times the height. Oops, I wrote 1/2, but it's 1/3. 1/3 pi r squared height. And our last shape that we're going to look at is the sphere. Circle, dot, 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 dot. And we've got our radius. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. And so those are your formulas. You just plug in the information to get whatever other information out that you want. So let's see if we can do, let's do one example. Let's find the surface area of a rectangular prism. Okay, my height of this prism is 7, width and base, height, whatever, length and width, 2 and 3. So I want to know what the surface area is, I want to know what the volume is. So I'd like you to go ahead and try this, and then I'll do it together with you here in just a second. So go ahead and pause. And now let's do it together. So The surface area is all of these sides added up. So I need this side, which is 7 times 3, 7 times 3, and I need another 7 times 3, which is on the other side, plus 7 times 3, plus, okay, so I got those two sides. Now I'm going to get this base here that's 2 times 3, 2 times 3, and I need another one of those because that's there on the top, 2 times 3. And now I'm missing this front and back here, so this is 2 times 7. And then again, 2 times 7. So if this is a 6-sided object, I have all 6 sides. 1, 2, 3, 4, 5, 6. So I've got all 6 sides. Now I'm ready to start doing some computations here. 7 times 3 is 21, plus 21, plus 6, plus 6, plus 14, plus 14. Add those together. This is going to get me 42. This is going to get me 12. This is going to get me 28. These are going to get me 40. 40 plus 42 is 82. My surface area is 82 units squared. Now my volume is a little bit easier. I just say the area of my base times the height. So this one, I just say the area of my base, which is 6, times my height, which is 7. 7 times 6 is 42. And this would be units cubed. One on top is units squared. All right, hope you guys got that okay. And it is now time for you to do your homework. Good luck. Oh, it's almost test time.